Right, you can see the slides, learn pattern matching by writing game. My name is Łukasz, you can find me on the internet. I come from Poland, arrived by plane and then by train. Like, I love the Netherlands, it's very, very nicely connected. These days I work as the CPython developer in residence. So I'm the first person ever hired by the Python Software Foundation to work full-time on Python. Not even Guido got that job. I mean, like, it's the best job ever. I'm also the release manager of 3.8 and 3.9, but as we all know, those are already like old crusty versions that you should just move away from right now, because Python 3.10 is out, and with that, there's pattern matching. So, well, what is it? Like, is it your new favorite feature, like f-strings, or is it a controversy that'll kill the language and you know, will cause us to switch to Clojure or whatever? So yeah, so let's find out, right? Like, let's learn pattern matching. We're going to go through some examples. This talk is, you know, perfect for people who have never seen pattern matching before, so that's probably most of you, so it should be fine. The examples today will have a theme, right? So it's going to be a game very loosely inspired by Isaac Asimov's I, Robot and related books. Very loosely inspired by, just like the movie, you know? So I rewatched it just 2 days ago because I was like, you know, what if this is a really bad movie right now? And I just remember it from 18 years back as a kid, you know, saying, hey, there's robots, it's cool. You know, it's got Will Smith. Like, at the time, Will Smith was also cool. So, you know, like, I was like, I need to rewatch it. And in fact, I found it quite nice. It is way different from the books, but the story kind of makes sense. So, you know, yeah, fine, like, not an embarrassing slide then. So let's make a game that recreates this scene, you know? But actually, this is how it looks like, you know? Like, speaking of embarrassing slides, like, it won't be a AAA game, right? Like, it won't be a 3D FPS. There won't be 4K resolutions and whatnot. There won't be HDR. It will be a terminal application written in Python 3.10 with the help of Will McGuigan's textual library, which itself is backed on his rich library for, you know, text formatting on the command line and async IO. So yeah, everything that I like. Why go through all this trouble? Well, when you're learning something new, like a new skill, like I find that if you have a plan to write an entire application, this is how you get the most experience, because it kind of forces you to finish things that you would otherwise kind of skip through on a tutorial or, you know, a blog post or a YouTube video or however people are learning these days, I don't know. So, well, I like learning, but I also forget things all the time. So I keep a lot of notes, and I mean like a lot of notes. Like, I cannot really trust my memory, so there's really like notes on everything, right? I keep them in a Git repository, and the notes are in Markdown, but they have also like attachments, and, you know, and there's JSON for metadata. But I'm not insane, right? Like, I use a GUI application to edit this. I don't use Vim for that. This is FS Notes, an open source Ukrainian Mac and iOS application that is a very nice user interface on top of what I just showed you on the slide before. For example, this public tag that I have here, I wrote like a Python script so that I can actually publish it as my website. So I just write notes, and some of them just end up being public and others not. And hopefully I'll never make a bug in my script so non-public things don't become public. But, you know, so far so good. So yeah, like, this is like under 1,000 lines of code in Python, so I highly recommend you do the same. You know, because then you can analyze them in pretty magnificent ways, right? Like, you have like notes that you can, you know, then do machine learning on. So for example, you can translate them, you know, I still write some things in Polish, so, you know, I can translate them when I'm searching for a thing, right? And when I'm searching for a thing, sometimes I don't remember the exact word I used and which language I used. So that helps me. So I highly recommend you do the same. So keep notes, own your data, and automate with Python. I guess some people learn by writing machine learning for, I don't know, like Bitcoin trading to get rich, and I write scripts to tell me which of my iTunes playlists are the saddest, you know? Like, people are various and different. But coming back to our app, apparently sometimes I get inspired to make little roguelike games that are supposed to have something in common with Asimov's novels, but really don't. Just like Apple TV's TV series that was supposed to be based on Foundation novels. When I learned, like September 24th was the date, I was like, oh, I need to learn. I need to read all the books so I don't get spoiled by the TV show. So of course, like back in 2016, I found some blog post and I kept it in my notes, like what is the one wholly true order in which you should read Asimov novels. So I'm like, okay, shit, like I won't read all of them, but I will probably be able to read like one or two, and this is what I did. But it turns out that this is what the TV series is based on. So fail. Yeah, like it still spoiled me a bunch, but you know, it's a good TV series, it's fine. And I discovered Asimov, he's really cool. Like some of his work from the 1940s and 50s is kind of dated now, but not a big issue. I kind of view it as a retro-futuristic, and if you view it like that, it's actually pretty inspiring. Like he also is an inspiring person, you know, per se, because like, you know, he wrote very many books, and people asked him like, what do you do to be so prolific? And when he said, well, you have to have a full schedule, you have to borrow from history, think harder than others around you, be overconfident, forget perfection, and remember about death. Well, like, I guess like it's just like, hey, we have limited time, so you need to just, you know, cram it well. On a different occasion, he said that no amount of rewriting and repolishing a detail will get it right in this moment. So in the absence of knowledge of the course of the entire project, you cannot know what you need. So let it limp and get on with it. And with that, let's start our application, since I already talked too much about Asimov. So for this app, we're going to need Python 3.10, otherwise there's no pattern matching. Since I'm using fish as my shell, we're going to use VF, well, that's virtual fish, to manage virtual environments. And I'm going to be using like poetry for, you know, like this kind of entire project. Like it may often show this because like, you know, like people are like, hey, how do you set up projects these days? Like 3 years ago, I would just show them black and it's like, hey, this is how. But like now I'm not so fond of pipenv anymore. And you know, again, that's what I do these days. And we're going to use textual, right? Like, in kind of big disclaimer here, this is a very new library. So there are rough edges on it yet, and well, for sure the API is going to change, but it's already plenty fun to work with. So we're going to start an application now. I'm not going to be typing, since like it would be very terrible with one hand. So I'm just going to show you a bunch of VS Code screenshots. So like when you start an application, it's here, so nobody sees this here. Like you just have a class, right, that you subclass from app in textual, and you just run a method called run to just start your application. Like now we're gonna have like a arrow that's gonna be higher up screen, don't worry. And that class, like it's just something that is provided by textual, and Will is very into subclassing, and he's very hard into like, we're going to be using this class for everything, and it's going to be magical and whatever. Like it's kind of like different from all the Python I wrote so far, but I found it interesting to actually discover how all this connects. So there's going to be plenty of like magically bound methods. For example, like this on_load is an example of like event handlers, right? So if you have an event like load, the textual will search for a method called onload on your app, and if it's there, it's just going to call it. And it can be either a regular method or an async method, and this is always true for textual code. You can always just put async in front of a method and it's going to work, or you can just skip it if you don't need any awaits inside. So yeah, like, the thing is, here it says send before going into application mode. So you set up a bunch of, you know, key shortcuts and whatnot, but what's that application mode? Like if you ever used Vim or Emacs or Nano, like, you know, like it just fires up an entire screen, like full screen application in a terminal, right? Again, if you didn't, maybe use top or use less. So this is the sort of thing. So here we only bind key keys to actual actions, right? So to something that's supposed to happen when you have a key pressed. Like the nice thing about this is that, you know, if you're new to like async IO and this await and whatnot, like don't worry about this. There is not going to be much of it in this talk at all. But the reason it's there is that whenever you're awaiting on something, like it's kind of happening in the background, and at the same time, the application can listen to other events, like for example, mouse, which textual fully supports. So you can do like a bunch of nice mouse-related actions as well. But here we're setting up actions for the keyboard. So if you're a seasoned async IO programmer, sorry, I know, like this is an anti-pattern here, like, and if you're new, like this is an anti-pattern to call await in a loop. Like the reason we have asynchronous programming is so that you can just execute things at the same time. So if you just do it in a loop, it's stupid. But you know, let it limp and get on with it, right? So we'll optimize that later. The important thing here is that we set an action to be executed with a given key, right? And actions are another magic method of textual, right? So it will just look for an action underscore. See how high that is? Like everybody sees it today. Cool. So action underscore toggle sidebar doesn't actually do anything. It just toggles the Boolean, right? But that was a magic Boolean because textual is reactive. If you use React, you're like, oh, okay, this is the same. No, but it's kind of the same idea. So if you have a reactive attribute on your app object, like what it's going to do is it's going to let you know whenever its value changes. And when it does, it calls another magic method. So watch underscore show bar happens whenever that method changes. This is nice because now we can, for example, animate changes to the layout. So here is where it happens. So it's like literally one line. I just added the log when I was debugging stuff. Since when you have a full application mode application, PDB stops working because, like, you know, all your keyboard and mouse interactions and drawing on the screen is taken over by textual. So if you have a bug, it's a little weird to fix. Like, you know, people who are hardcore are like PDB doesn't work. Like people who are less hardcore, it's like print also doesn't work because we're like, you know, full screen applications. So you have to log all the time. So let's see how this looks, right? Like if you have this application, you just press I or, you know, use the button right there with the mouse, and it kind of animates. Like it tears a little because iTerm on macOS tears a little, and there's nothing we can do about this, but good enough for me. Yeah, so how did I get those things to appear in the first place? So there was onload where we just did like keyboard shortcuts, but now there's on mount. So after we become the full screen application, we're doing actual layout of some widgets, right? And there's a bunch of widgets here. You know, you have like this level display, panel tree, game header, game footer, like you name it. And you dock it into views. Like, you know, all of this is, now I'm lying, none of this is documented because it's a new project by Will. But there's plenty of very good examples inside the GitHub project. So I just based on that. And when I failed, I just went in and read the source code, which is entirely type annotated, which if you're not a fan, you're like, but like, hey, you can click through everything in VS Code and everything works. You can see where stuff is defined because it's all type annotated. So I liked it, you know? So the sidebar is docked on a higher Z plane. You have the Z equals 1, which is why it was so nicely kind of covering the rest of the screen when it was animating out. But so that it doesn't cover the footer and the header, I had to create this another dock called main screen, just so that, you know, like those things don't get obscured. Details. So you probably noticed this game.inventory thing, like what's going on? Well, we have to store the state of the game somewhere. So I do it in the most primitive manner possible. There's a bunch of data classes, and they're very short, right? You know, there's an inventory that holds a list of items and the index of the current one. There's a game that holds the inventory and the level, which is literally just a bunch of text lines. Well, like literally a bunch of text lines. Like if you see below, like there's this global object, like bah, global state is terrible, right? But like not in a game that you're starting. It is an interactive application. There's not going to be any networking on there. You're not going to have like 2,000 requests per second. It's very easy on everything. So you can just have a global state of the game. There's just one player. And it literally reads some level from the disk. Not elegant, but works. And what it does is it lets me design levels, you know, like I'm 10 again, you know, and like ASCII art, you know, it's great. So yeah, like this is nice because you have like those roguelike style walls, and you have the underscores that say you can actually step on this place. You have some like robots and, you know, like a chest and the character. But you might have noticed it's kind of a little weird that like there's like robot says RR and chest says CH and your character is 2 X's. So like what's up with that? Well, kind of too late in designing this idea, I discovered that like, hey, like emojis are double width, right? So like when you have like this thing like inside, like it takes the width of 2 dashes, see, like right below it. So it is a little annoying to design, but like it's fine. Oh, what I wanted to show you here as well is that when you're actually clicking on the inventory items, like it'll change the item that you hold, right? Like because you can use it now and you can do something with it. Yeah. So handling clicks in a tree is done here in this handle tree click. It also would be just a single line if it weren't for the fact that I'm checking whether which tree is this coming from. Like in my app currently, I only have 1 tree, but maybe in the future when this is becoming, you know, the next Minecraft, like, you know, maybe I'm gonna have more trees. So I already foresaw this. See, like limping is bad. Like you need to foresee stuff. Yeah, but anyway, we have inventory clicked and we check stuff here. Like, and here, those are the most boring, like, kind of ways of programming in Python, right? Like you have is instance, like are we clicking on the entire inventory? That's a data class as you remember. And if so, was it loaded already? If so, we can just toggle visibility. If it hasn't, we're just creating the child items right there. Or if it's already a single item that we clicked on, let's just set it to be the current one. There's a type ignore here, because the current thing is a property that has a different type on the setter than the getter, and MyPy doesn't like it. Well, typing. In any case, we're changing the subtitle too to just tell the user, tell the player that we're holding a new item. And see, like there's this, you know, square brackets, BB code style formatting that you can do in Rich. Like I like it a lot because it's the simplest idea possible to just do like markup in a command line application. I like it a lot. Yeah, so for example, here like you have this toggling that is await because it actually takes a little bit of time to re-render this. Yeah, like later I will have like to implement like actually updating the tree data if, you know, somebody drops an item or uses it up or picks something up, but actually this is where I am at the moment with the game. In fact, like you can do a bunch of stuff like, you know, move around and then you try to open the door, but you know, it won't let you. So you select a different item that you have, and with using that item, you pick the lock and you can walk around. Like, not much interesting is happening like until we get to that, you know, place where there's robots. And then there's robots, and you cannot get to them because I designed the level wrong, and it doesn't align with double width. Yeah, I need to get a better level designer. Oh, but I almost forgot, like, we were supposed to learn pattern matching by writing a game. The title says it, right? Yeah, like my conclusion is that you should never do anything by writing a game, you know? Like, you'll just end up yak-shaving issues with a framework that you use to write the level editor for the engine that you're still writing for the game, so you end up not doing the thing and not having a game, you know? So, like, don't do it. No, do it anyway, because writing games is fun. It bonds you with your kid, you know? Like, I'm a bigger hero for writing this shit game to my kid than I am for being the core developer in residence, you know? He doesn't give a damn about that other thing. So yeah, like, it fulfilled my childhood dreams, so it might fulfill yours if you had any that like, I want to write a game. But most importantly, again, you learn the most if you have an issue like in a project that you want to finish and you need to get through it somehow. It doesn't matter how, like, you know, you have to power through it. Sometimes it's like an actual, you know, production application that people pay for, and sometimes it's a stupid game. But some of you would be like, hey, this is just cheating yourself out of a Keynote. I want my money back, and I also want my reimbursements for the hotel and travel from the organizers. So, like, let's talk about pattern matching just for a minute. Yeah, on the left, what you have is the old inventory clicked thing, right? Like, it has a lot of instance checks, and it has an if and else that are internal to that one instance check. But it's kind of readable, it's obvious. And on the other side, you have alien Python. It's alien because it's not really Python. And I mean it, not a joke. So let's just highlight that and just now talk through what the hell is happening here. So first of all, this is not a switch statement, because switch statements would work exactly like the rest of Python. For example, if you had a class inside, what that would mean if that were a switch statement, which it isn't, was that you would create a tree-node object, but you are not creating a tree-node object in a case, in a case. What you're doing instead is you're creating a pattern, right? It's a case pattern. And what that pattern says, the first one that we see straight below the match, is that any node that matches that happens to be an instance of a tree node with an attribute called data that happens to be an instance of an inventory class, then we want to hold on to this data inside, right? We don't need this entire node. We already have it kind of as a name, but we want to hold on to this internal thing as data, and we can also match on other things. So like that tree node that we already know, okay, it has data that is an inventory instance, needs to also have an attribute that is called loaded, which happens to be true. So in this one example, we already went through like, you know, like 300 words on the PEP that describes pattern matching. So it's like we are matching on types, right? And we even managed to do it as a tree, right? Because there's a external node, and we're looking inside it to see there's a class right here that is an object of the inventory type. We hold on to that because later we actually want to use it somehow. And it's loaded true or loaded false. So that other example here, the second case, that's the only difference. It matches when loaded equals false. And when it does, like, we can do stuff with it. And in this case, we actually use the data that I held on to as a variable, because we are using data.items here in the enumerate. As you can see, I never actually assigned to data in any other way. The as is what that does. So yeah, like those are the two. And then below, what you probably cannot see unless I kneel, is just tree node data equals items. So now we don't want a tree node that is the entire inventory data class. We want one of the items. So we just take that and just set it to, you know, to be the current item. Yeah. So does it look scary? Oh, hell yeah, it does. I'm a core dev, and I'm like, what the hell is this? So is it going to destroy Python? Well, no. Like, assignment expressions compared to this is like a tiny, tiny feature, and it got Guido to just quit. You know, he was like, I no longer want to be the BDFL because it was so stressful to actually get that feature in. And now nobody talks about it because it's a small feature that we didn't really, you know, felt like we were forced to use. I use it every now and again, like probably in my day job, which is literally Python. I would use it once a month. But when it when it does appear useful, it is very useful. Assignment expressions, very useful for regular expression matching and a bunch of other small use cases. Everything else, just do regular assignments. You know, it's one line more probably sometimes no more indentation, but it's fine, right? And I believe, that's my personal belief, you know, not PSF affiliated, is that match and case are going to be the same. They're going to be super powerful features that sometimes you do use, and it's fine. And then you have to spend some extra time reading what the hell just happened here. Like, if you are already familiar with this, maybe this will feel less alien. But if not, it's okay, because you can still use the equivalent on the left, because there's nothing that you can do with match that you couldn't do without it. It's just more convenient. As you can see, there's fewer lines up here than up here, and there's fewer levels of indentation here than here, right? But like, other than that, they are pretty equivalent. Those examples are kind of weird, but this is a true example that I found coming back again and again. When you have a bunch of both type checks that you need to do, so is instance checks, is subclass checks, and a bunch of value checks. So you're looking at some particular attributes. This is where pattern matching is nice. Like, the other examples that are in the PEP and whatnot, like, I find like, okay, they're very cute, you know, they're nice to have, but not so useful in my particular experience. But, you know, like, you're listening to a guy who writes shitty roguelike games, you know, in his free time. So what do I know? In any case, that pun was unintended, I'm sorry. If you still think, hey, this was a shitty tutorial of pattern matching, you'd be right, you know, because there is a better one right there. There's a specific PEP that says structural pattern matching tutorial, and I highly recommend it because it also doesn't do it in shitty, like, dry manner. Instead, what it tells you to do is to write a text oh shit. That was learn pattern matching by writing a game. Thanks.
Thank you very much. If there's questions, there can be questions. We have some time, so let me give you the mic.
Just curious about the pattern matching. Does it always match only one case, or it can have multiple matches?
Yeah, we only have one life. That's the problem. All right, so let's go back to the slide. That's what I can do right now. So pattern matching can match on things that are inclusive, meaning you could say, for example, that I want a data that is inventory, or, and you're using the ugly bitwise or, a different type. So we can use or. So we can kind of have like a compound pattern by using ors. You cannot use and I find that weird. I don't know why. Like, I need to ask Brand, like the author of this, like why the ampersand is not available here as well. I would find it useful to just say, like, you know, I want all of those things to be true. But then I thought, you know, but like, all the things that I'm already writing is kind of like an and, right? Like, I'm writing that I need a tree node type that has the data attribute set to this thing and the loaded attribute set to this thing. So it's already kind of that already is, you know, multiple things in one. That would already be an and inside an if statement, which in fact it is here, right? Like in the old style example, you already had like an instance, and inside you had to check whether node.loaded is true, right? So there's two ifs, an and, right? And here on the right side, you have a case and another case, right? Like, so, I mean, yeah, like there's no and, but there's or. I haven't shown it, but, you know, kind of, I just don't find it particularly, you know, exciting. It looks like the union type, like here on the top, you know, so you can just say, I want this or that. Probably that was the inspiration of the syntax. In fact, the biggest controversy about pattern matching was that this syntax here inside the case is now different from everything else in Python. So are people gonna like it or hate it? Well, if they hate it, they might just, you know, kind of skip through it. It's fine. But it's less alien than regular expressions, I guess, right? Like, it's still kind of Python-ish You know, you can still read it as such. Yeah, I don't know. I started talking.
Two more questions, I'd say. Anyone? Okay, 1 second.
I'm just trying to get whether I understood it right, but am I correct in assuming that the S data is redundant in the first and third case? Or do you need it?
Cool. So the weird thing about as data is that it applies only inside the case block, right? So it's a scope. It's a new scope. So this as data might have been different from the one that you're going to have on another case, right? And on this case. In fact, the first one right here is totally useless because we're not actually using as data in this particular case, but I didn't know this when I was refactoring. But the second one is definitely used right here, and the third one is behind me. You'll never see it. Yeah, so they're not redundant because each case is a new scope, right?
Last question. Anybody? Go. All the way in the back, almost.
Hi. Match statements in other languages sometimes have exhaustive matching on enums or stuff like that. This is not possible with the current syntax, except you can add a catch-all at the end or something, but nothing enforces that you actually handled all cases. There's a few different answers, I guess, but can you enlighten us on what you think is the most Pythonic, or do you see syntax extensions in the future?
Mike is coming.
So free beer for you after, because it's a great question. So the fact is that Go sucks, don't quote me on that, because it doesn't have exceptions. And Rust rules, but it doesn't have exceptions. Why? What's the difference? Well, but because for the former, what you need is a keyboard that instead of enter, you have if error isn't equal to nil, you know? And with Rust, you don't have to have this. Instead, you have to have a very, very big apostrophe on your keyboard for Rust. In any case, Rust, the way it works, doesn't need exceptions because it has pattern matching that is exhaustive. What that means is if you have types that are unions of, say, a success and an error, what you need to do in a match statement in Rust is you need to spell out all the possibilities, right? So here, for example, it would be awesome, but it's impossible, if the match node case here would actually check whether we tried both inventory or item, which is the type of node that I said in the annotation in the signature. But we cannot do that. And you know why? Because in Python, an object can be anything. And it can change its mind about being of a single instance, like right there when you ask it. It's impossible to do anything statically because everything is dynamic. So like the entire thing here, like the entire kind of genius of this particular implementation is that it does a lot statically already once you compile it, because otherwise it would be super slow if it did all the kind of naive checks like dynamically every time you ask for them. But it can only go so far. So there is no exhaustiveness. You can kind of maybe imagine a MyPy plugin that would do this, right? But the MyPy people are unwilling to do stuff like this because it's not in a PEPs, and I'm unwilling to write a PEP about this. So, kind of maybe you can write a PEP. The nice thing, for example, that MyPy could do is tell me, hey, I forgot an await. It would be the best thing ever because, you have a coroutine that you just created and you threw away because it's not assigned to anything. So you just created it needlessly and you threw it away. It's an error. It's an obvious error, and MyPy knows it. And it won't show it to you because it's not a type error. Like, why? Why can't you just be useful to people? I don't know. Like, in any case, pattern matching is not a replacement for exceptions. Not in Python.
And on that bombshell, I'd like to end.